Damn Russians' fault. All right. I'm recording, but I'm not going to pull up anything. I'm going to pull up the whiteboard, and we're going to do 2 or 3 problems, and y'all going to say y'all came to class today. Capiche? We're going to do some trig substitution. This is the first part of trig substitution. And we'll go over some more when y'all get back. So I'm going to put some trig substitution homework, and I would highly suggest that you do it over the break so you don't forget this stuff. And I would highly suggest I'll extend it. It's going to be due, it says it's due Saturday, but I'm going to extend it because y'all need to work on it during the break. In fact, I would rather you work on it like 2 or 3 days before you come back rather than now. So, I mean, you got the videos to record. I mean, you got the videos to go over the material. But as of today, we've learned how to I don't know where the heck this thing came from. What was that? What is that? Oh, your computer. So far in integration, you've learned how to do the power rule. That's the basic. You've learned how to do substitution. That's the second basic. That's where you have u, du, and you put something here, like a 2 here and a 1/2 here. You remember doing that back when we first learned how to do this integration? That's substitution, basic substitution. And then the third, we learned how to do integration by what? Integration by parts. And what did that encompass? In other words, what part of integration did that cover? This covered your basics. This covered if you had to manipulate. What did this cover? Remember I told you not to say it in math class because some teachers would have a cow? Well, yeah, ultraviolet minus voodoo, good. But it's integration, it's kind of like an integration what?
Just like doing.
Huh? What was that, Skype people? Okay, somebody just stand up. Integration. Look back in your notes. Integration product rule. Integration product rule. Y'all remember the announcement, Skype people, you remember the announcement about your mic being on? Everybody can hear you. Yo, Skype people. Mic's off. Anyway. And then we had what? Trig what? Trig integration. And the trig integration was basically trig powers or combination, well, trig identities. Using trig identities. to manipulate the integration. And then what was and now the fourth one is what? Trig substitution. So with the derivatives, we learned how to do what? The basic power rule. We learned the product rule, we learned the quotient rule, and we learned several other with derivatives. And now we're learning several different applications of integration. The whole purpose for Calc 2, in my opinion, is to teach you to drill integration and derivatives, to where it's like factoring to you was with algebra. You learned it, and then you drilled it until when you were in calculus, you went, oh yeah, factoring. I know how to do that. Well, that's what you should be doing with trig substitution. I mean, that's what you should be doing with integration and derivatives, antiderivatives, whatever, integration and derivatives. When you get to Calc 3, you should be going, oh yeah, I know how to do that. And you should be able to just do it. The third thing you should be able to do in Calc 3 is to be able to think out of the box like you thought with the work and the rates of change. Okay, now together, you're going to take those two things and you're going to combine them with particle in space. And how fast is a particle in space going, blah, 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 the velocity of a particle in space, finding the normal vector, blah, blah, blah. Now, when we get to the last unit, we're going to be talking about drawing in 3D space and all that good stuff, and that's the next unit. Because I'm going to skip all the crap. I'm not going to go into all the crap. You can get all the crap, the theory and stuff, when you're going to be a math teacher. Okay? You can get that in advanced calculus. But trig substitution is what we're going to get now. And in order for trig substitution, you've got to learn three things. You've got to memorize three things. And that's these three things. Oh, my back. My back feels like, oh. The square root of a squared minus x squared is equal to x gives us, x is equal to a sine of theta. The square root of a squared plus x squared gives us x is equal to a tan theta. And a squared, x squared minus a squared gives us x is equal to a secant of theta. Now just a couple of mentions here. One of the things people say is, well, how do they get that? Well, go back to your Pythagorean. Go back. If you wanted to find, let's see, this is x, y, and h. And sine is equal to opposite over what? Oscar hat, Oscar right here. So that would be sine of theta. Sine of theta is equal to y opposite over a hypotenuse. I don't know why they put O and H, but anyway, let's just do that. O and there we go. Opposite over hypotenuse. And the hypotenuse and the opposite is equal to the other side minus, and you take the square root, and it goes back to h is equal to the square root of o squared plus a squared. You incorporate that into this, and you get this. That's where that comes from. So I'm just gonna, you just draw this right here, and this is where this is coming from. It's not something that you just see this unit. No, it comes from this. Okay? And that's where that comes from. Another thing you want to, so number one thing you need to remember is this. Number two, and this is very important, number two. If you notice, these things are in terms of x. This is your number usually, and this is your variable. Number, variable. Variable, number. Okay? Everything in these guys is in terms of x. Now, start with terms of x. And then you go from terms of x into terms of what? I'm pointing at it. Huh? Yep. And then after you go from terms of theta, you turn back into terms of x. Now that's what we're going to be doing during this section of trig substitution. And of course, all this is the bad word manipulation. You're manipulating, starting with terms of x by using your basic trig. You're going to turn it into theta, and then you're going to take theta and turn it back into terms of x. And some people like to look at this as a puzzle. It's kind of like when you start with a puzzle, the first thing you do is find all the corners, and then you start with the edges, and then you work your way, unless you're Rain Man or the accountant, and then you just start putting stuff, you can't find one piece and you start going crazy. That was a good movie. I don't like Ben Affleck, but that was a good movie. It was good. I watched Kong last night. It was good. I don't like King Kong. I don't like the whole series. I never have liked, just like Godzilla. I don't like Godzilla. But that was a good movie. I watched it last night. I had to wait until the Russian version went off. But then the American version came on yesterday, I think. That's the problem with the Fire Stick. You have to wait till. I can handle Russian subtitles, but when they're speaking Russian, I can't make any head or tail out of it. But that was a good movie. Oh, I watched another good movie, Miss Sloane. Y'all seen that? That was a dang good movie. It was about this lobbyist in Washington. That was a dang good movie. All right, so in order to do trig substitution, you have to know these three things. Now, these three, this would be the square root of 3 squared minus x squared. This would be the square root of 3 squared plus x squared. And this would be the square root of x squared minus 3 squared. Okay. So that's what I mean by the variable and the number. All right, so let's see if we can do one. Start off with something simple. You might want to, on these problems, you might want to keep a page open because I do every step, and some of them take, this one takes a page and a half, but I write you probably give you a page. Well, 2 pages. 2.5 pages. All right, so I must have had the flu because the flu gets you back. Feel like a 90-year-old man. No comments, please. I don't want to hear it. X cubed over 16 minus x squared dx. All right, the first thing you want to do is say, okay, what do I have? Well, you've got x cubed dx over the square root of 4 squared minus x squared. And now you know what you're dealing with. So you look in your key, trig sub key, and you've got a minus symbol, but you've got the number first and the variable second. So that means we're dealing with what? Sign. So you go over here and you say x is equal to 4 sine theta. Now I want everybody to make sure you understand where you get that. I'm going to move this over because I don't like the way it's sitting. What? Yeah, a little bit. And I'll do the maybe that'll help. Now the second thing you do after you do, and I'll do this, after you find x, what do you think we're going to find after we do x? Dx. So if x is equal to 4 sine of theta, what's dx? Just set up your 4 corners of your puzzle right there. Now, wherever there's an x or anything that's relatable in this original problem, I want you to substitute in x and dx. Go ahead and do that. That means instead of x cubed, you're going to have what? 4 sine theta quantity what? Cubed. So plug in everything you can using theta. We're putting everything in terms of theta now. So, parentheses, Q, 4 sine theta, dx is what? 4 cosine theta d theta, all over, well, we got 16 minus x squared, so we're going to be square root of 16 minus 4 sine theta, what? Squared. Focus on the bottom. 4 sine theta. I'm not focusing on the top right now. Okay, now some of y'all should see something in that bottom now. Anybody see it? Yep. Pull the 16 out. Do that. Now does the 16 stay in the radical? Yes, it does. But you haven't taken the square root of it. Go ahead and keep it under the radical, factor out, see what you get. What does that open up when you factor the 16 out? One minus what? Sine squared theta. And y'all should say what? What's 1 minus sine squared theta? Cosine squared theta. That's right, class. Y'all suck. And what's the square root of 16? And I'm going to go ahead and write the square root right here of cosine squared theta. And then the next step, you could take the cosine, take the square root of cosine, drop that off. And now we can focus on the numerator. Four sine theta cubed 4 cosine theta d theta over 4 cosine theta. And what happens to the cosine? What happens to the 4 cosine thetas? Four sine theta cubed d theta. And now what do you have? We remember seeing that in the last section. You've got a sine raised to an odd power. Remember that? What do you want to do? Change it to 4 sine squared theta. Well, yeah, change the pull 4 out. Pull 4 to the third out. And you'll have sine cubed theta. And then that sine cubed theta, look back in your notes from last week. 4 cubed sine cubed theta d theta. And look and see if there's a sine cubed theta. Integration of sine cubed theta. It should be. I'll have to look and see. Because it'll take y'all 3 or 4 days to do that. Well, there's a cosine to the 4th. Sine cubed theta. Sine to the 5th. Okay, sine to the 5th. I still thought there was sine cubed somewhere. I guess not. Sine to the 5th. So take that to the next page. So that'd be 4 to the 3rd. Four to the 3rd, antiderivative, sine cubed theta d theta. Well, the first thing you're going to do is rewrite that as sine squared theta times what? Sine theta d theta. Now remember, the rule of identities say always put in terms of sine and cosine. Well, in this case, we have it in sine and sine, but that's not going to help us, is it? So we've got to change one of them in terms of what? Cosine. You don't want to mess with this because this is your key right there. You don't want to mess with that. So that means you got to change this into something of cosine. And what's that going to do? Good job. And what did I teach you to do in the last week's section? And after you do that, what do you do with this guy? Distribute. And after you do that, you should start to see something. And you can put a bracket here and put another integral here. Now take the integration of sine, and what is the, if u is cosine squared, what is du? What's the derivative of cosine? Check, make sure you got your sheet. What's the derivative of sine? I'm sorry, derivative of cosine is negative sine. So that's going to make, got to put a negative here if I'm correct. Negative here, that means I got to put a what out here? A negative here, which would make this a what? So that means I've got 4 to the third. The integral of the sine is the what? I'm going with what y'all tell me. So you need to check your paper. Thank you. Plus, what would that be? The u to the third, which would be cosine theta over 3. Let's see. Let's see what I got there right. Yep. There we go. And you can factor out that negative right here. Factor out this negative, and it'd be negative 4 to the third cosine theta minus 1/3 cosine cube theta. So let's see. Now you feel good about yourself, but there's only one problem. What do we start with? So we got to put it back in terms of what? So you need to write that on the next page, and we need to somehow get it back in terms of x, and you're going to use your key. You're going to use this right here to help you get there. -4 to the third power cosine theta minus 1/3 cosine cubed theta plus c. I'm going to bring in my key. X is equal to 4 sine theta. So I'm going to solve that and say sine of theta is equal to what? X over 4. Well, we know the sine is opposite Oscar had, right? So that's O, and that's what? So we got a handy triangle. And that means that opposite is x, and hypotenuse is what? So if we wanted to find out what this was, what would it be? The adjacent side, what would it be? It'd be square root what? 4 squared minus x squared, which we know in the beginning of the problem is what we were doing, but this is just a way to check it. Okay? So that's the way to check it. So therefore we know that the cosine, what would the cosine of theta be? Cosine of theta, Oscar had a hump, would be the square root of 4 squared minus x squared over what? 4. That would be cosine if you needed it. And we do need it right there. So now what are we going to do with the sine and the cosine? What are we going to do with them? Plug them back in to get everything in terms of x. So, -4 cubed, and what is cosine of theta? Square root of 16 minus x squared over 4 minus 1/3, and I'm just going to put this in parentheses, raised to the third power, and go square root of 16 minus x squared over 4 plus c. And that is the antiderivative of what we started out with. We find it. The antiderivative of x cubed over 16 minus x squared dx. There's not really much you can do with that, because that 4 is in, you have to fix the the radical with that third, so that would be exponent over index. So that would be 16 minus x squared to the 3 halves over 4 to the third, 4 times 64, and then 64 times 3. I don't know what that is, 192. So that's about all the, you could, or you could factor out, you could pull all that out and cancel it with the -4 to the third power out there. You could maybe clean it up a little bit. That's about it. But as far as the setup, that's the setup. Or not the setup, but that's enough of an answer for you to get the credit. All you can pull out is a 1/4. So it's still in a mess. So it's like that. But as you can tell, 1 started with x, 2 terms of theta, 3 back to what? Back to x. All right, let's try nerd. I'm going to let you work on it. dx over the square root of 9x squared plus 4. All right, you start that. You start on. I'll give you about 5 minutes to work on it. You should be able to make a little bit of progress with it. Did the heat ever come on? Turn it down. Turn it down a little bit more. Just bring it all the way to the bottom. On the side. Is it all? Yeah, all the way down. Well, thank you. That should help. But if they still got the air conditioner turned on, it's not going to help. So. Or the Russians have to. So the President of the United States enforces another ban, and a little podunk federal judge out in BFE says there's not enough evidence, and he also says that anybody entering the United States somehow is protected by the Constitution. I'm like, what? I tell you what. These people, you know, as I said, when we went over to Kuwait back in 1990, there was about 15 or 20 protesters that went over there, and they were holding up signs It says we love you, Iraq, and all this. And you know what they did? They cut their heads off. These people that are taking up for these people, I'm not talking about Muslims, I'm talking about crazy people. Yeah, liberals. I'm sorry, I think it's Muslims. You're not supposed to say Muslims. It's Muslim, I think. I ain't got no problem. Just like I don't have no problems with Christians, but I got a problem with people like Klansmen. And that's exactly what we're talking about. We're talking about nut jobs. Liberal nut jobs. Muslim nut jobs. You want to come to the United States? That's fine. You want to salute the flag? That's fine. You don't? Get the hell out. Simple as that. I don't see what's so hard about it. Kaepernick found out the hard way, didn't he? He can't even find a freaking job. He's gonna be on the what do you call it? Unemployment roll. You don't bite the hand that what? You don't bite the hand that feeds you. And you don't show disrespect to the capitalism that puts money in your pocket. Damn Russians. Let me make sure y'all are here. I gotta say no class for Tuesday. Whatever day, yeah. Because y'all probably gonna get an email that says I haven't turned in. No, I get that email. You haven't turned in your attendance. Oh. Let's see, I was here Monday. Tuesday, I wasn't here. So that means I got to do 141 Tuesday. No class. And I'll get an email about that. You put no class. Did your class meet? Oh. 110 Tuesday. Alright, who's here today? Ahmed is Skyping in, Anderson is Skyping in, Bradshaw is Skyping in, Edwards, okay, is here, Grant is here, Butts is here, Khalil, I don't remember seeing her Skyping in. Miss Khalil, did you Skype in? I think she did. Mr. Nabay is here, Patel is here, Fear Skyping, Scobie Skyping, Sheik is not here. Silver is here, Thompson, I think he's Skyped in, Tucker,
I'm here.
Skyping in, Wizenhunt Skyping in, Williams Skyping in. Make sure everybody's still here. Okay. Okay, so what y'all come up with? Y'all finished? Which one is it? Well, rewrite it. Oh. I'm sorry, folks. My back feels like I've been run over. Dx over square root of what? 3x squared plus 2 squared. right? So we have the variable squared, and we have the number squared. So isn't that the tangent? 3x is equal to tan theta. Okay, now you need to look at that and make sure you understand how I got it. Okay, it's turned on yet. Now, I want you to get your key ready, if you haven't yet, of that. You got two things you got to do. What is it? One, you got to solve for what? X, and then you got to take the what? Derivative. So do that, if you haven't yet. I'll do the first part for you. X is equal to 2/3 tan theta. I'll do that for you. What'd you do? Did it come on?
Well, down was 4.
Huh?
Down was 4.
Oh, I'm sorry. It turned all the way up.
Yeah, it's missing it.
I suck. No wonder my back's hurting. It's probably arthritis. That dumb cold. X is equal to 2/3 tan theta. So dx is equal to 2/3 secant squared theta. That go, I remember that. 2/3 secant squared theta d theta. Okay, now there's your key. You need to highlight that because that's what you're going to use in the next step, and you're going to use it to return back to x. So that's very important. So come over here and start substituting. You should be able to substitute if you haven't yet, because practically doesn't happen for you. So dx is 2/3 secant squared theta d theta over the square root, and you could put 3x 2 tan theta in there squared, and plus 2. That's all you're going to be able to do. Is the square root of 2 tan theta squared plus 4. All right, start working it, start manipulating it, start churning it. I'll give you a hint. Pull the 2/3 out. If you still can't do it, then you're a failure. That's what I need. I need to go get me about a gallon of ginger ale. I'm sorry, ginger ale. I don't even think I can take it. Some of you have never been in the state of drunkenness and hangoverness to where you say you'll never drink again. That's the way I feel about eating right now. I haven't eaten since Monday night. And I really am not too high on eating right now. The only reason I think I might have had the flu is because of my back. Isn't that what's supposed to happen? Doesn't it make your back hurt? Y'all suck. Haven't we got some wannabe doctors in here? No, doctors have to take calculus. Because you got to have up to Calc 3 to get into medical school. Calc 1, 2, and 3. Oh, I got some good news. One of my, remember telling you about the student that procrastinated and didn't come see me during pre-advising and waited till Christmas break and then threw a fit down in the lobby because he couldn't get me? Remember me telling you about that guy? He just made the dean's list at Clemson and he just took Calc 3. So he's doing good. He was one of those people that was undecided on majors, and I told him, I said, you'll take up to Calc 3. Then you can go into any major you want. And he still hadn't decided which major he wants to go into. But, like you just said, if he wanted to be a doctor, he would go to medical school now, because he's got Calc 3 under his belt. And so, I'm very proud of that. No, because they want to teach all the Calc 3s.
Oh no, it's not even offered. The 240? When did they offer it? Because I didn't take it this semester because it was
Write a letter, write an email. Did you write an email?
Yeah,
Write an email.
the way to do it.
I'm serious, write an email. Because he's getting a lot of emails. It's stupid. The main thing is request to be offered. That's the main thing. We need to worry about teaching. All right, so I'm going to pull the 2/3 out. Secant squared theta over. I'm going to put 4 tan squared theta plus 4 under the radical. What'd you say? I'm sorry. Let's forget to do theta. Let's forget to see. And then we'll rewrite that and we'll factor out what down here. And you're starting to see, after you do the second or third problem, you'll start to see a pattern. Now that square root 4, you can pull it out and do 2's cancel and get 1/3 out front. So go ahead and start doing that. And then of course, then you got tangent squared theta plus 1 is what? Secant squared theta? I think it is, right? Huh? And then secant squared theta is cancel, or secant. Take the square root of secant squared. So this one is a little bit easier. Y'all should be able to finish it. If you can't, then we all know what that means. So 2/3 secant squared theta over 2 square root of secant squared theta. And that's going to be 1/3 secant squared theta, d theta, over secant, which is 1/3 the antiderivative of secant theta d theta. Now the antiderivative of secant theta is natural log of secant tangent. So secant plus tangent. So go ahead and I'm going to take it over to the next page. I'm just going to make it smaller because I don't feel like doing that. I'm going to keep it all on one page. So that's going to be 1/3 the natural log of the absolute value of secant, y'all checking, secant theta plus tangent of theta. Okay, now this is your setup, but it's not the answer because now you've got to put it in terms of what? Using your key up there. Now you got to do your triangle because you don't know what the secant is. So x is equal to 2/3 to, let's see, 3x. Tangent of theta is equal to 3x over what? Oscar had a hump of apple. So of is 3x and apple is 2. So this is going to be 3x squared minus 2 squared. Sine, cosine, tangent, cotangent, secant, and cosecant. The secant and the cosine. Cosine is Oscar had a hump, hump A. So the secant of theta is going to be the square root of what? 9x squared minus 4 over 2. Y'all check it. And there's your new key to substitute back in. Now, doing these two problems, they may be long and drawn out, but you should see a pattern. You should see a methodology. Step by step, you should see 1, change everything in terms of x. 2, theta. Then get everything in terms of theta, then transfer it back to x. So, 1/3 natural log secant is the square root of 9x squared minus 4 over 2. Make sure I copied that down right. Plus, what's the tangent? Tangent is 3x over 2 plus c. So the antiderivative of dx over square root of 9x plus 4 is all that. So you kind of could say, I don't know if that's grammatically correct, that this is kind of integration by quotient rule. Could you? A little bit? Because aren't you dividing? All right, who's got questions? Now, there is a difference. There is a couple of problems that, like for instance, I'm trying to think of one. What if I gave you something like this? Well, I don't want to turn. What if I gave you the antiderivative of x dx over the square root What if I gave you that? Is that trig substitution? Okay, that would be a yes or no answer. Or you could say, I'm just going to stay silent because I suck. Which one are you? Okay, you all suck. It is not trig substitution. Why? Well, I could change that to a square. You could change that to square root of 2x quantity squared plus square root of 3 quantity squared. Get used to that because you could do that. So I could change it to a square if I wanted to. But why isn't it? Remember your substitution. Make u equal to something complicated. What is u? Well, 2x squared plus 3. So what is du? 4x what? dx. Now I have the antiderivative of u, what? Du of what? U. So this one is one that a lot of teachers put on tests, and people think it is trig substitution, but it's not. It's just regular substitution. The number 2. Let's go back. I didn't erase it. That would be right in here. So you see how it could be. So you've got to know the difference between the two. Question. All right. Y'all get out of here, have a good break. I will put the I can't talk right now.